Hello everyone, Mr. John here for Airteam Institute's Introduction to Algorithms. Today we are going to be talking about the topic of search. So this is an English word, right? We know kind of what this word means. So we want to just start with a little bit of introduction discussion of what searching means, right? So you might think of searching as, okay, I lost my keys, I need to try to find them, where are they located, right? Or I lost my textbook or can't find my textbook, where's my homework, where's somebody's assignment, different things like that. We also have a little bit shifting into more programming things, right? A lot of times when you hear the word search, you will think of search engine, right? So you can think of Google. Notice that this is still somewhat the same idea. They're trying to find something, you're giving them some words, they're looking for those words or looking for websites for you to kind of use to come up with the information you're looking for at that point. So in general here, what the kind of idea is, right? We're trying to find an object or information, right, in some location. So I want to kind of separate it into these two parts here, right? So we have kind of trying to find some object, right? We're looking for our keys or our assignment, or we're looking for a website in some particular form, and we have some general idea where to look, right? That location could be broad, right? I'm not saying you were searching for your keys only in your room, right? You might have to also look outside your room. Maybe they're, maybe you left them in the car, or maybe you left them in the kind of door or things like that. But in general, we're trying to find an object in some location. Now, today, right, we're going to have a slightly more focused approach, or at least in terms of the programming and algorithms we look at, right? So today, search will mean kind of a very specific question. So we have an element and we want to know, is this element a member of this list, right? So of course, these things can be asked in either order, right? Does this list contain a specific element, a specific term? And then this is a yes, no, or of course, true, false answer, right? So I want to kind of stress that here. Our kind of answers are either it's yes, right, which we would refer to as true, or no, which we would refer to as false, right? These are the two answers we have available in this case. So yes, no, true, false, is this element a member of this list? Now, right off the bat, this is a common theme for a lot of our stuff, right? Of course, Python can do this, right? And it uses the very simple syntax in. So if you type the command 5 in 4367, it's asking roughly, is 5 a member of this list, right? And so of course this, in terms of an output here, is going to be true, right? So this is a false statement here, right? So this one is false here, right? 5 is not a member of the list 4367. 5 is a member of the list 3456, so this will be true, right? So notice here just a little bit about Python. They're talking about numbers, right? We have a list of numbers here, so 5 is in this list of numbers, right? In the second case, not in the first case, right? And in the third case, right, is the string yes in this list of strings? No, yes, maybe. Of course, this is true here as well. So yes is a member of this list, so we kind of want to be a little bit careful there. Now, Python, right, as with any programming language, does stuff pretty strictly and pretty rigorously. So let me just give a quick caution here, right? What if I do the command 5 in 3456, right? This will return false, right? So we want to be slightly careful here, or kind of be slightly kind of cautious about the different forms of input we are providing, right? So here 5 is like a string. And so that string is not in the list. There's no errors involved, right? You can put numbers and strings, right, in a list. Remember, we kind of talked about how Python doesn't really care about that. Lets you sort out those details. But it's not going to like try to compare this string 5 with the number 5. Those are not the same thing. They are not equal to each other, right? And so that will return false in that scenario. Okay, so of course our questions then are, we don't care that Python does this. We want to kind of look a little bit deeper, right? How is this actually implemented? What are the different ways you could implement this, right? What is the big O runtime, right? If we implement it this certain way, what are the advantages? What are the disadvantages, right? Things like that as well. Now, the kind of analogy, the example I want to kind of be thinking about in terms of a real world example throughout this video is kind of locating a guest who may or may not be staying in a hotel, right? So we kind of have our hotel, right? Maybe we have a bunch of kind of different rooms here. And so then we want to kind of look for, we have a person we're looking for. We don't even know they're staying in the hotel, but right, we want to check whether they're there. And, we have the different rooms we can look there. Now, of course, all of these real world things kind of are a little bit annoying, a little bit kind of detail oriented. We don't want to worry about like, are the people going to answer the door, right? If you knock on the door, that person will come out, right? They're not trying to hide from you or anything, but we want to kind of just think about this example of locating a guest and seeing what we can do in this hotel. Now, one of the things we'll see is that a lot of these algorithms or a lot of different methods are going to depend on actually some more background information. So, right, these hotels will have varying degrees of organization, and that'll kind of correspond to, as far as lists are concerned, or as we're kind of moving forward in the future, right, we're going to do a little preview of some stuff to come, what other background information or extra organization could help us out along the way. Now, especially with the hotel example in mind, right? What happens if the hotel has no organization at all, right? There's no front desk attendant there to help you, right? There's no directory, nothing. You just know, here's the rooms, right? Good luck. All we can do, and right, the best thing we can do, I want to stress here, there's nothing better we can do. We just have to say, knock on the first door, is Joe here? Yes or no, right? Second door, is Joe here? Yes or no, right? We search all the rooms. If we find Joe, great. If we didn't find Joe, well, we looked at all the rooms, so we know that Joe is not there, right? So this is the idea behind sequential search. So to look at this as far as kind of an algorithm is concerned, right? This one's fairly simple, right? One by one, we're going to go through the list, check if we found our element. If we ever find it, then yes, we're done, return true. If we never find it, right? If we search the whole hotel or whole list and never find what we're looking for, we have to return false. And there's nothing really we can do to make that better or worse in that case. So let's take a look here at kind of an implementation of this. So this is taken from our book here. We have our sequential search algorithm in the definition, right? So we're defining this sequential search, and right, the ordering here is a little bit different maybe than you might have originally thought, but right, it's a list and then the item we're looking for, right? So this is of course equivalent to, let me just kind of note that right off the bat here, in terms of Python and stuff, this would be equivalent to the command here, item in a list, right? So this is asking, or this is kind of implementing that same exact command there. We're looking for the item in that list. So that's what we would be doing here. So remember, as far as our hotel was concerned, what was the idea? We go and start knocking on the doors one by one. Definitely our kind of default position is we have not found the person, right? So we want to start at the beginning, right? We have not found the person. So that's kind of our first set of commands right here. And then what happens? We start looking through all the rooms one by one, right? So this is our kind of looking by the rooms one by one in this case. So right here, right, we have now looking at the rooms one by one, checking the position. So right, while we haven't found the element and we haven't reached the end of the list, so while we haven't found our item and we haven't reached the end, right, keep looking element by element, right, item by item through the list there. So that's kind of our scenario for the algorithm in this case, right? So kind of piece by piece, if we're looking at the code, right, you have your current position, right? Check if that element, right, the index associated with that position is what we're looking for. If it is, we kind of set our found thing to true, right? We could, right, there's different implementation. You could just return true at that point. That would be pretty much equivalent to this statement, right? If we haven't found our item, move on to the next position. Move on to the next door in the hotel that you knocked, right? Check if you found it. If not, move on, right? And then at the end, you kind of return, you check back in, have you found the item or not, right? So that is our kind of implementation here. It's a fairly simple implementation. If we kind of look at running the code here, we have two things that we're checking. We have some vowels. So we have, okay, set the vowels to be A, E, I, O, U, right? I don't quite want to get into, maybe we have a sometimes Y. That doesn't really work with our programming here. But we have our 5 vowels, and then we want to check, is basically E a vowel and is G a vowel, right? So then if we looked at running this code, right, we found E the first time, and the second time we did not find G. So then we kind of are done either case. So just to kind of be clear and kind of go through that a little bit as well, right? Again, if we're doing this sequential search for E or G, right, regardless of the one we're doing here, you're just going to start going through that list one by one in this case. So, right, so searching for E in a sense here, right, and this is a little bit more details maybe than we need, right, but you kind of do here, right, you ask the questions, is A equal to E, right, and then you say no, right, and is then kind of E equal to E, and I'm not doing official Python code here, of course, right, we would need the double equals, so here we would have yes, right, and so then, right, kind of found equals true, and we're done. So that's kind of the procedure we would have in this case. Okay, so we'll summarize this kind of on the other slide again too, but I think it's good to think about, while we have the code in front of us, what we can say about runtime here. So what can we say about runtime? How kind of efficient is this algorithm going to be? What are some of the things we can say about that in this case? So couple of things here. Hopefully it's kind of fairly clear that this is kind of going to be kind of O of n in total, right? So we're kind of looping through the list, right? So the idea behind O of n, right, is we kind of loop through the entire list looking for the element, right? So this is kind of your worst case scenario in a sense, but according to some of our calculations before, things like that, O of n maybe is okay in a lot of scenarios, right? We're kind of looping through the elements one by one, so we kind of could search through the whole list, maybe not the whole list, things like that. Yeah. Now, I do want to talk a little bit here about kind of best case scenario, worst case scenario, right? Average scenario, things like that. And I want to mention them just to kind of mention why they maybe don't make as much sense in this case. So if we think about the best case a second here, so what is kind of the best thing that could happen to us in the problem, right? So the best case would be the first door we knock on in the hotel, right? Or the first element we check, right? We find as the first element in the list, right? And so in this case, this is constant, right? So this is kind of O of 1 in this scenario, right? Of course, there might be a couple of different steps. There might be a couple of different checks or things like that, but it's some constant number of kind of things there, right? So the worst case is kind of here, right? We maybe never find the element or find the element as the last kind of element in the list. Never find or find as the last element, right, in the list. And so this is like clearly an O of n case here. Now, right, why do we want to kind of oftentimes think about worst case, well, or think about kind of the different scenarios here? And what gets a little bit weird, right? So what about the average case? So you might kind of think, well, okay, if it's in the list, maybe we kind of find it in the middle, right? But there's some other questions here. What are you searching for, right? Are we going to be in this worst case often, right? This isn't like you're randomly searching, right? A lot of the times you might kind of search for, right? If we're searching for words, right? More often, or sorry, if we're searching for letters, if I'm searching even for a random letter, more often than not, it's not a vowel. So kind of in that case, more likely we will have the worst case than the best case. Or, right, even if we're talking about vowels, maybe we're searching them like by, right, them showing up in words. Well, E is going to show up much more than U, right? And so in terms of kind of even an average case, maybe we're going to be stopping towards the beginning of this list at A and E much more often than we're going to be stopping at U, right? So average kind of still is going to be pretty complicated, right? So really depends on the types of inputs, right? But probably still, right, O of n. So yeah, so sorry for my code still kind of loading here, right? But this kind of average here is kind of probably still an O of n situation in this case. But again, we don't really want to kind of worry about those too much because it really, really depends on the types of inputs and things like that you have here. So let me kind of take this all back to our screen here. Let me delete this portion, but we can kind of keep some of this big O stuff here as well, right? So we have our different kind of cases and stuff like that. And maybe delete the average kind of case here and say, just kind of replace that with kind of a summary here, right? On average, this really depends on our kind of known, or on our inputs or situation. So those are some things we want to kind of keep in mind, right? In the next video, we're going to be talking about sorting. And so that's another thing where this is going to be very, very important to kind of think about, really depending on our inputs there. Okay, before we move on to some other sorting methods quick here, I want to stress this situation seems a little bit funny as far as the hotel being organized, but in practice, you probably can't do, or in many cases, you maybe can't do better than sequential search, right? So in practice, sequential search is pretty good. Because, right, often our lists will have no organization. So I want to kind of stress that there as well, right? If we don't have any organizations of our lists or things like that, right, we maybe have no option other than to kind of search through the list one by one, right? If I just give you a random list of names and you have no idea if they're in any order or anything like that, you have to search through them one by one, pretty much. And so in practice, this is how a lot of kind of things would be organized, with the caveat that we will see some other options in a second. Okay, so let's talk here about our next option, which is binary search. So now when we get to our second hotel, this has some very useful properties here. All of the rooms are full with guests that are willing to share their name. So we can kind of knock on one of the doors, someone will come, we can say, are you Joe? And they will say, no, I'm, right, Mike. And then we can kind of go from there. And much more important here is all of our rooms and guests are organized in an alphabetical order. So how can we use this to our advantage, right? Well, if we kind of say, for example, the rooms are numbered, right, 1 up to blah, 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 right, in kind of alphabetical order with guests in alphabetical order, then, right, for example, let's go back to Joe and Mike, right? Then if we check room, right, 20 for Mike, or for Joe, right, and find Mike, we know that Joe must be in a room from 1 to 19 if he's at the hotel, right? So of course he might not be there. So we don't know that Joe is necessarily in one of the rooms 1 to 19. But if we look at room 20 and find Mike, right, M is after J in the alphabet, right, we know we have to look before that to find Joe if he's there, right? And so this is a much more kind of restrictive scenario, right? Because now our guests have to be in alphabetical order. What is this going to kind of be like in general, right? And this is also a preview for our next video, right? In general, right, we need to assume our list is sorted in this case, right? So our list needs to be in, some sort of sorting here. And in a lot of these examples, right, it's maybe easiest to think about numbers, right? So we're kind of looking for a list of numbers, right? And so we find a number and then we say, is it higher or lower? Or if you were using a dictionary, right, you could do something like this, right? I randomly open a dictionary to look for a word, right? You're playing Scrabble or something and arguing about, is this a word or not, right? If you randomly open it and you kind of find, right, marsupial in M, if you're looking for something before that, right, you know where to look in the book or after that, right? So this kind of is a way to kind of start dividing things up, right? And this really is a situation where kind of things can be divided into pieces there. So to kind of explain the implementation of this, or a way to implement this, let's go to the code again. I'm going to do this kind of not as much details because all of this code is taken from your textbook. So, right, if you want to kind of look at this as far as implementations are concerned in your kind of textbook, you can go from there for some more details here. So I do want to kind of draw a general picture here on the side. So suppose we have kind of here our list. So this kind of is our list we're looking for here. This is the list of elements we're kind of looking through as far as our terms are concerned. And so then what do we have here at the beginning? Well, we have kind of a start position and an end position, right? So these are kind of indices, right? So we have a first and a last. So we have kind of these two things here. So this kind of is first and last. Let me label those here quick. So first, and then we would likewise have a last one there as well. So first and last elements, and right, those are coming from this code we have right here. So first and last, and then seeing what are the things we can say from there. Okay, so while first is not less than, or is less than or equal to last, and we haven't found our element, right? This is our kind of loop we're going to be doing here. Now, the general idea here is exactly what we mentioned before, right? So what do we do here? Well, we look in the middle. So here we have our middle. And then from there, we kind of search on either side, right? So we look at our middle element. If we found our thing, if we found our person, if we found our number, right, in that case, right, this, to clarify, is a binary search of numbers. If we found our number, great. Otherwise, right, we have to look in one of the other two pieces here. So examining this else statement right here, just to kind of explain this pictorially, right, what happens is if our item is less than the middle element, then we change our last element to this middle element, right? Then we now focus on our portion here. Then what's the next step going to be? Of course, the middle becomes the middle of this portion, and now we're kind of at a smaller thing there. In a sense, we're dividing this in half, right? What if it's kind of not smaller, right? What if it's larger? Well, then we move the first element, right? Then we move the first to kind of up here, right? We have our middle element, now the first comes up, and now we repeat it. Now our while loop continues in this half there. So the general kind of idea is we're cutting this down in half each time. And so this is one of the things here we're going to be talking about in terms of this kind of big O runtime and stuff as well. The other thing I want to point out really quickly here is, right, this also can lend itself really nicely to a recursive algorithm, right? So the other way to do this then, right, you can also do this in a recursive method here. I'll let you guys think about that a little bit more as well. But it actually kind of does the same thing. It's the same type of organization that we have before, right? Instead of now having like our first middle, last, and stuff like that there, right? Well, actually, let me keep one of them a second. Let me keep our middle element here, right? We start with our list of elements. We look for the middle. So we look for our middle element here. If we found our item, it's true. That's great, right? Otherwise, and here is again the dividing by 2 happening, right? Otherwise, we kind of look at the list before, right? We look at the first half of the list. So remember here, if we're using this slicing operator, right, which maybe isn't the most efficient in this case, but, right, we're not worried about that right now, right? You're getting this kind of here, and then you just look in that list, right? If you haven't found it already, okay, I now, divide and conquer. That's often how these recursive algorithms will be called. Look at the first half, right? If, right, you haven't found it, but we know it's greater than the element you have there, well, now divide and conquer, but look at the second half, right? So if we're larger than this, right, this will look at the kind of second half here. Okay, so one thing I want to just caution here really, really quick. I don't want to dwell on this here. So caution, this code, and so if we look at the code actually here, you need to modify the code to remove these kind of slicing. The slicing element here, if you're actually going to think about the runtime and stuff here, you actually need to remove that slicing to achieve the kind of most efficient code, to be more efficient. So when we talk about the runtime, I'll actually be lying to you a little bit as far as this particular implementation of the recursive algorithm is concerned. But, right, the other one works fine. You can modify the recursive algorithm to work this way. It's all okay. I don't want to worry about those details right now. Okay, back to the slides then here, right? We kind of said how we can use this to our advantage, and the idea is we check the middle, right? So we take our list, we divide it in 2, and then we kind of continue in that case. So if we find the element, great, right? If we don't find the element, right, cut it in half, and now we kind of have our piece here. Whoops, not a line again there, right? Then we have that kind of smaller piece in this case. Or it could be on the other side, right? So we have this then here, we have our kind of dividing point in the middle, and then, right, okay, now we're kind of looking at this piece as well here. Now, if we're talking about big O runtime, let me put some actual kind of numbers here. And the middle portion, right, I want to kind of ignore that middle portion here, right? And so roughly speaking, if we say we have roughly a list of size 16, right, then we cut it in half pretty much, right? So the midpoint stuff is a little bit annoying, but we kind of cut it to size 8, right? Then we would cut it like to size 4, right? Then it would be like 2, then it would be 1, right? So notice the pattern here is roughly, notice at each stage, we are roughly dividing our list in half, right? So half, 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 over and over and over, half, 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 stuff like that. So this is kind of the opposite of, right, multiplying by 2 each time. And so what this is giving us is kind of this logarithmic behavior, right? So I don't want to talk too much about kind of the details here, right? But this could be kind of log here in. And so really here, of course, this is a base 2 logarithm, right? So base 2 logarithm. And so that's kind of our idea here, right? When we're doing this divide by 2, each time, right, 16, right, 8, 4, 2, 1, right? This is kind of reverse exponential growth in a sense, which is our logarithmic growth. So that's how kind of this runtime would work. Remember though, this requires you have a sorted list to begin with here. Okay, as our last little thing here, I want to do a preview of kind of the best case scenario. This is something we're going to talk about in the future. So this is a preview of something called hash tables and stuff like that here. So our last hotel here has a very useful, but maybe not realistic, right, properties here. So it's like either an exclusive hotel or something like that, right? So every possible guest has a dedicated room, a dedicated and unique room that they stay in, right? And further, the front desk attendant can tell you that information. They don't know if the person is there or not. So we still don't know if Joe is at the hotel, but you can go ask the front desk attendant and you ask them, oh, is Joe here? They say, so let me just kind of type this out quick. So for example, right, you can ask, is Joe here? And the front desk attendant unfortunately can't quite tell you. So this is a little bit weird, but this is kind of the best way to make the analogy work, and we will see. And they could say, right, I don't know, but he always stays in room 202, right? So they don't know if Joe's here or not, but they'll say he always is in 202. So if he's here, he will be in room 202. Notice this is very, very helpful. So we only need to check room 202. In a sense here, this is O of 1, right? So this is very, very nice. This is a very, very nice situation we have there, right? This is the nicest kind of scenario. It's not super realistic. There's some complications here, right? But roughly here, in this example at least, we would have to check one room. And so this is something we'll talk about a little bit later when we get to kind of these different data structures, ways of organizing data. One of them will be a hash table. So you could think of this almost like a school locker as well, right? You have a unique locker at school, and then you could store some stuff in your locker in that case. Okay, so that's going to bring us to the end of our video today, right? We kind of talked all about search. In particular, we did two implementations, right? We had one talking about sequential search and binary search. So remember, you can always look at your textbook for more examples of that. And then look forward to the next video, which will be talking about some basic ways to start sorting, some basic sorting algorithms that we will discuss then. Goodbye.